Good morning. We're going to work on a couple problems today so that you have some tools in your toolbox. And you're going to notice that both these examples are going to be expanding a logarithm using properties. There is a couple problems though. Because of the technology I'm going to use, I'm going to leave them as just natural logs. And when I'm doing the first example, I'll show you what happens um, what if I use a different base. This is the limitation of the technology. So we're going to start with the natural log of the product of 12x cubed y to the fourth. And if my memory is correct, the natural log of a product is the sum of the natural logs. So that's the natural log of 12 plus the natural log of x cubed plus the natural log of y to the fourth. Now let's play with 12 some. I believe 12 is the same as 4 times 3. So this is the natural log of 4 plus the natural log of 3 plus the natural log of x cubed plus the natural log of y to the fourth. I tend to like to wait till the end when I'm going to use powers. Now I'm going to use my multiple rule, which says the natural log of a number to a power is the power times the natural log of the base, the number. Well, 4 is 2 squared. So I can rewrite this as 2 ln of 2. 3 is just 3 to the first, so I can't do anything there. Plus 3 ln of x plus 4 ln of y. Now let's take a look at this using some dynamic computer algebra based programs. Bam. Okay. Let me move this so you can see what I'm about to do. Expand. And I come down here to natural log of 12 times. And let me use these buttons. This will be x. That was x cubed. Cursor. Then I want to go to times. Power. Y, and I think we had that to the fourth. And what? Unable to match. Oh, I know what I forgot to do. Okay. Let me try this. Just got it to work a second. Okay. There we go. Notice it just did that, so the natural log of 12. So it breaks it up. There are some limitations. Now let me see if I can that's interesting. You know what, I'm just going to try this. Let's see if I can do it myself. And computer algebra systems, as you've seen, are very messy. No, it's not letting me break that up. But now you can see that it does know that the natural log of a product is the sum of the logs. And there must be a way that I can trick it to do the rest part. Now, let's go back and take a look at the second problem, which is a little bit more work. So, well, actually, it's a lot more work. I just had to do that for you today. So, the natural log of a quotient. So, we're going to use a few properties. Notice we have a quotient, we have products, we have powers. Let's see what happens as we work through this one. Okay, so here I am, I'm working through this one. And I'm going to start with the big picture. The big picture is I have a quotient. And the natural log of a quotient is going to be the difference of the natural logs. So the first step is going to be, this is the natural log of the quantity x cubed times x minus 1 squared minus, and right here my warning bells go off, the natural log of a product of y squared z cubed. This first one is the natural log of a product, which will be a sum of natural logs. So I start with, this is the natural log of x cubed plus the natural log of x minus 1 quantity squared. Now look, these are going to be ready to apply my multiple to. I'm going to make a common mistake, and then I'll show you how I'll fix it in a second. I go minus. Well, and some kids rush into their demise. They're like, oh, okay, this is a natural log of a product. That's the sum of the natural logs. Okay. ln of y squared plus ln of z cubed. However, that's wrong. Use some grouping symbols, now it'll be right, because they both need to be in my denominator. And to finish this up, this is 3 ln of x plus 2 ln of the quantity x minus 1 minus 2 ln of y minus 3 ln of z. Now here's what I'll normally do when I'm contracting things. If I see a bunch of subtractions, I group them and then I factor out the minus so I can see them as a product, but I know they're in my denominator. These are just little tidbits. I hope this helps. I'll see you in class today.